Welcome to our last lesson on probability distributions. Today we're going to talk about finding values. We're kind of going to come at this from the backside. So what we've done so far is we've used z-scores to find probabilities. We're going to reverse that this time, and we're going to use probabilities to find z-scores. Find a z-score that corresponds to a cumulative area of 0.362. So here's our normal distribution, and cumulative means that we're coming from the left. So if you come from the left, first you run into the first 50% of the data, hop over the mean, and you get the second 50% of the data. We're interested in the cumulative area of 0.362. So it looks like this. We don't quite hit the full 50% of the data. So you grab your calculator, hit second vars, distribution, and then you're going to go down to inverse normal, and put in the area that you're interested in this case 0.362. If it's on an old calculator, this menu might not come up, and you just need to type in 0.362, hit enter. It tells you that the cumulative area of 0.362 corresponds to a z-score of negative 0.35. Let's try another one. Find a z-score that 15.5% of the distribution's area is to its right. We want to the right, but here's the problem. Cumulative area comes from the left. But we can do this. We'll just take 1 minus 0.155, which gives us 0.845. We'll use that number to find the area up until that point. So second vars, go to inverse norm, put in 0.845, and that tells us that that sectioning off point is the z-score of 1.02. Find a z-score that corresponds to the 5th percentile. Well, the 5th percentile means that 5% of the data is below a certain point. So that's what we need, an area of 5%. So same process, inverse norm of 0.05 gives us a z-score of negative 1.64. What if we want a z-score that corresponds to the 95th percentile? Up to 95%. We'll plug in 0.95 into our calculator, and this time we get a z-score of 1.64. What if we need to find the z-score for which 60% of the distribution's area lies between negative z and z? So we've got two z-values, and we know that 60% of the data is between them. But we need the cumulative area. How do we find that from the left? Well, if we know that 60% of the data is in the middle, we know that there's 40% left over. So we can divide that by 2, and we get 20 on the bottom and 20 on the top. Now we can use that. Inverse norm 0.20 gives us negative 0.84. The positive of that would be the positive z-value. So we can just say z equals plus or minus 0.84. We're going to take this one step further. So far, we've done probabilities to z-scores. Now we're going to take z-scores and actually find x-values. So the speeds of vehicles along a stretch of I-25 are normally distributed with a mean of 66 miles per hour and a standard deviation of 4 miles per hour. Find the speeds, x, which correspond to these z-scores. Z equals 1.96, z equals negative 2.05, and z equals 0. So we're just going to set up an equation. Our z goes on the left, 1.96. The value that we're trying to find is the x. Subtract the mean, divide by the standard deviation, and then just use your math algebra skills to solve for x. Multiply both sides by 4, add 66 to both sides, and we get x equals 73.84. What does that mean? That means the speed of 73.84 miles per hour is 1.96 standard deviations above the mean. Let's try the next one. Negative 2.05 equals x minus 66 divided by 4. Same thing, use our algebra skills, multiply both sides by 4, add 66 to both sides, and we get x equals 57.8. That means that that speed, 57.8 miles per hour, is 2.05 standard deviations below the mean. What about z equals 0? We can set it up the same way. 0 equals x minus 66 divided by 4. Multiply both sides by 4 and add 66. We get x equals 66, which means that 66 miles per hour is the mean. And anytime you get a z-score of 0, you're talking about the mean. So that's it. That's the end of our unit on probability distributions. We found area, we found probability, and now we found values. Thanks for being here.